Hey everybody, welcome to the last video of this unit, which is about rational inequalities. And this video actually relates quite a bit to the last video that Mr. Lakin did in Unit 8A, where you're checking your intervals on a number line and seeing which intervals work. And it's a combination of that old video and the third video in this unit, which is about common denominators and rational equations. So before we get to some examples down below, I want to take a look at this example here, the simplify. Notice that this is not an equation. So because we've been spending so much time on equations, if you're ever asked to find a common denominator, and you need to because this is really 4/1, remember that you can't just multiply by the common denominator unless it's an equation. So if I looked at this, and we're going to come back to this problem later, if I wanted to get a common denominator, I would have to multiply top and bottom of this one by the denominator of 1 plus 2x. And if I did that and continued, the top, now that these are the same denominator, I can combine the fractions, and your denominator will be 1 plus 2x. And on the top, or the numerator, you'd have 5 plus 7x. And then you'd distribute the -4 and get -4 minus 8x. Notice that I'm not writing an equal sign because it's not an equation or an inequality yet. But if I wanted to get a common denominator, my final answer would be 1 plus 2x on the bottom. And on the top, if I combine like terms, I would get 1 minus x. So keep this in mind because we're going to come back to this problem a little bit later, which is connected. But I wanted to do this to please point out that if it is not an equation, we can't just get rid of the denominator. So let's look at the steps to solve the rational inequalities. Similar to the problem I just did, we want to bring everything to one side and simplify. We generally want to find a common denominator, if applied. We want to find critical numbers like you did with Mr. Lakin, where if you factor and set equal to 0, those are the numbers you put on the number line. We're going to create intervals and check them to see which ones are true. Just like Mr. Lakin's video, we're going to pick numbers that make it decently easy to check, and then we're going to write our intervals in interval notation. So again, let me come back to this problem, and let's start instead with this example. Now the first move, if you remember, was number 1 was bring everything to one side. So if I subtracted 1 over x plus 3 over here, I would get 1 over x minus 1 over x plus 3 is greater than 0. And then if I want to combine these, I need a common denominator. And so what you could do is think about, well, the common denominator, or LCD, is going to be x and x plus 3. So this fraction has the x, but top and bottom needs x plus 3. And this fraction has the x plus 3, but top and bottom need the x. And all you're trying to do is get a common denominator because we're not completely solving. We're using a number line to check our answers. So if I simplify this, this would become x plus 3 on the top over x times x plus 3 on the bottom. And this one would become x over x times x plus 3 on the bottom. If I wanted to make this into one fraction, it now has the same denominator. So we would have x times x plus 3 in the denominator, and the numerator would be x plus 3 minus x. These would cancel. So you'd end up with 3 over x times x plus 3 is greater than 0. And so now what we need to do is think about how can we use this to find our critical numbers. Well, there's a few things we need to pay attention to. And before I do that, let me make this a little neater here. This is supposed to say x plus 3. So what we want to do is find those critical numbers like we did in an earlier video. And if you recall, when you have a fraction, you can never ever divide by 0. So that means that both x cannot be 0 and x cannot be -3. So I'm just going to write that as a little note. X cannot be 0, x cannot be -3. So on my number line, those would be considered critical numbers. However, because it cannot be 0, we could either put an open dot on 0 and an open dot on -3, or we could even use the notation with the parenthesis, like this, if you would like as well. Now what we need to do is check this interval, this middle interval, and this interval as well to see which ones are true. So let's start with this interval, and we want to see if we plug those numbers in here, if it makes it true or false. So a number that we could work with that's less than -3 is -4. So if I plug in 3 over -4 times -4 plus 3, that would be 3, and we want to see if this is greater than 0. That would be 3 over -4 times -1. So that would really be -4 times that'd be positive 3/4 is greater than 0. Is positive 3/4 greater than 0? It is. So this first interval works. A number that we could plug in from the middle would be maybe -1. So if I plug in 3 over -1 times -1 plus 3, that would be 3 over -1 times 2, or -3/2 is greater than 0. That is not true, so this interval does not work. In the third interval, we could pick +1, 3 over 1 times 1 plus 3. How does that relate to 0? So it would be 3 over 4. Does 3/4 or is 3/4 greater than 0? It is. So this interval works and this interval works. So in interval notation, my final answer will be from -infinity to 3 not included with a parenthesis, union 0 with a parenthesis to infinity. So this is my answer, and this is the type of answer your teacher will be looking for on a future test or quiz. And the test is coming up sooner than you think. So take a look through this, write down any questions you might have. We're going to be doing 2 more examples at least. Number 2. The good news about 2 is that we don't have to get a common denominator because everything's already on one side and there's only one fraction. But what we can do is notice that the top can be factored to specifically x plus 3, x minus 2, and the denominator is still x. And the reason this example was picked is to kind of talk about the difference between the critical numbers in the numerator and the critical numbers in the denominator. Now, in the previous one, we only had a number up here, so we didn't have any critical numbers in the numerator. So when you're looking first at the denominator, no matter what, this number can never exist on the number line because you can't divide by 0. So I'm going to write a note that we know that x cannot be 0 no matter what. However, in the numerator, we need to pay attention to what symbol was given to me. The critical numbers here are x equals -3 and x equals 2, if you picture in your mind setting equal to 0. Now, because the numerator kind of goes with the less than or equal to, both of these critical numbers are possible. So if on my number line I put 0, I put +2, and I put -3. The 0, I'll just use dots for now. The 0 would have to be an open dot because it's in the denominator. The numerator, because it's less than or equal to, both of these are possible to be included, so I'm going to put a closed dot on there for now. So now we have 1, 2, 3, 4 intervals to check. So let's see what we can do. We want to see if this number is less than or equal to 0. So again, I'll pick -4 for this first interval. And let me plug it into this one here. So that would be -4 plus 3, -4 minus 2 over -4. So this number is -1. This number is -6 over -4. So that would be a -6/4. Is -6/4 less than or equal to 0? Yes, it is. In this next interval, I'll pick -1. And you can make this faster if you'd like. If in your mind you're plugging in -1 every time you see an x, you could think this is a positive number, this is a negative number, and this is a negative number. So you'd get negative over a negative, which would be a positive number, which is not less than or equal to 0, so that is not a correct interval. Here, I'll pick the critical number of 1. So if I plug that in, that would be 1 plus 3, 1 minus 2 over 1. So that's a positive number times a negative number over a positive number, which is negative, which is what we want. We want this number less than or equal to 0, so this works. And I'll pick 3 as my number in this interval. and that would be 3 plus 3, 3 minus 2 over 3. Positive, positive, and positive is going to be a positive number, which is not what we want, so that interval does not work either. So it looks like my final answer in interval notation would be from negative infinity to negative 3, but this time negative 3 is included. So you could put a bracket on your number line. Union, now this actually, that shouldn't be a parenthesis. That should be another bracket because the other, well, partially, because if you take a look at this interval here, we have a included piece here and a not included piece here. So the union would be from 0 to 2. 2 is included, 0 is not included. So this would be our correct answer for number 2. Number 3. I want to give you a head start on this one. My hint to you is take out a greatest common factor on the top, but I want you to find the critical points, plug it in, and try it on your own. And I will come back in a bit with my final answer. Please pause now. All right, guys, so to check back in, here I took out a greatest common factor of x, so I had x and x plus 2. So my critical numbers on top were 0 and negative 2 if you set equal to 0. Because the inequality given was just greater than, negative 2 and 0 are both not included. And the critical number of 9 from the denominator is also not included because I can never divide by 9. So all three were open circles for me, or parentheses. When I checked my intervals, I got this first, I plugged in negative 3, and this did not work. I plugged them all into this one, by the way, right here. This was my one of choice. I plugged in negative 1 in here and got that bigger than 0. I plugged 1 in here and it did not work. I plugged 10 in here and it also worked. So that means that my final answer would be the intervals from negative 2 to 0, both not included, union 9 to infinity. If you got that, good for you. Now, if you would like to try one more on your own, there was a problem at the beginning that we already found the common denominator here. So if you're interested, what you'd have to do is move the 4 over. And we already found what the common denominator is. We already did this up here. So this can be replaced with 1 minus x over 1 plus 2x is less than or equal to 0. If you would like to pause the video and try this one as well, I will be back with my answer in a minute or two. So please pause now if you'd like to try this one as well. All right, guys, so if you tried this one, I got the critical number on top to be 1, and that can be included because of the less than or equal to. So I put an closed dot there. In the denominator, the number that x cannot be is negative 1/2, so I put an open dot there. I checked my 3 intervals with the numbers negative 1, 0, and 2. And when I plugged them into this one here, I got that these 2 intervals worked and the middle one didn't. So my final answer was negative infinity to negative 1/2 not included with a parenthesis, union included 1 with a bracket to infinity. All right, guys, thank you. Best of luck practicing everything together. Feel free to rewatch any video again if you need help with a specific topic. Yeah, wonderful. Thanks, guys, so much for sticking with me during Unit 8B. Good luck on your test.